Hey everybody, it's meteorologist Aaron Treadway. I hope y'all have been enjoying learning about the weather so far. There's lots more to learn. Even me as a meteorologist, even today, I've been working for 3 years after going to college for several years, and I still learn new things about the weather every day. Today's video is going to be a pretty short one. I'm just going to cover the atmosphere and a couple different things about it, the composition of it, the different layers. Just a really quick overview of the atmosphere. So there are four main layers of the atmosphere: the troposphere, stratosphere, mesosphere, and thermosphere. The troposphere, the lowest level, is the level that we live in, and it's where all the weather happens. I would say 99.9% of all the weather happens in the troposphere. The one exception is if you get a really, really strong thunderstorm and that updraft, remember all that upward air, is strong enough to punch through. It can actually punch through into the stratosphere. So it's not going to go really far into the stratosphere, but it can actually reach up into the next layer of the atmosphere. The gold line there that you see on the graphic is the temperature trace. So temperature either decreases or increases with height, depending on which layer of the atmosphere that you're in. So in the troposphere, it decreases with height. It warms in the stratosphere, the next layer up, due to ozone. So ozone is one of the components of the atmosphere, and it absorbs heat. And so the stratosphere warms with height. The other layer that warms with height is the thermosphere. It's that top layer, and that's because it's what's directly absorbing all of that solar radiation. Since it's closest to the sun at the top of the atmosphere, all those sun's rays, all that radiation coming in and getting absorbed there. What about the composition of the atmosphere? What are the gases and what are the different components of the atmosphere, of the air that we breathe? Well, it's mostly nitrogen. So you might be like, well, isn't it oxygen? Don't we need oxygen to breathe? Oxygen is there too, but the atmosphere is mostly nitrogen. One of the things that it actually does is it dilutes that oxygen in the atmosphere. If you strike a match, if there's a fire, it needs that oxygen to burn. Well, if there was more oxygen in the atmosphere, that fire would be a lot more explosive. It'd be a lot more rapid burning. It would kind of be out of control. So that nitrogen is actually a good thing because it dilutes that oxygen and makes situations like that not occur with fire. The other thing is our bodies and us as humans need that nitrogen to make protein. So the fact that it's almost 80% of the atmosphere is not a bad thing. Oxygen is there at 21%, so it's the air that we breathe. It's what we need as humans to live, is the oxygen. Argon is there as well, and carbon dioxide, what we breathe out, makes up the big four components there of the atmosphere. That's almost 99.998% of all the gases in the atmosphere, and then the other percentages go down from there. The one important thing is water vapor. So we've talked about the need for water vapor for weather in terms of the moisture that's needed, in terms of just all the little water droplets, and at times as much as 4% of the atmosphere can be made up of water vapor. Most of the time it's kind of 1 to 2%, but as much as 4% can be made up of water vapor. So one cool thing that I wanted to look at is then take the Earth's atmosphere and compare it to some of the other planets. So let's first look at kind of our nearest neighbor, which would be Mars. And again, where we're nitrogen, oxygen, and other components, the atmosphere of Mars is mostly carbon dioxide. So we would not be able to survive there without being able, to have a breathing apparatus, because carbon dioxide is what we breathe out. It's the side effect of us breathing, so we would not want to be breathing that in. The other thing is that our atmosphere is a lot more dense than the atmosphere of Mars, over 100 times more dense according to NASA here. But that's just one planet. Now let's look at all of the planets to wrap up this presentation. And here's an infographic that shows basically all of the planets. So as you can see, there's actually a lot of oxygen, that green color there on Mercury, about 42% of its atmosphere. Just like Mars, Venus has an atmosphere that's mostly carbon dioxide, so again, not really where we want to be. For the gas giants, Jupiter, Saturn, and Uranus and Neptune, they're mostly hydrogen. over 80% for all 4 of those planets. Helium is there with other gases. And then Pluto and Titan actually are a little bit similar to Earth. They have nitrogen as their biggest component in terms of what makes up their atmospheres. So they also have methane, and carbon monoxide, and others. But with this graphic, you can definitely see where Earth compares to the other planets out there, and very much, we're in a unique situation with Earth that makes it kind of the perfect balance for us to be able to live. So that's just a quick overview, a little bit of meteorology mixed with astronomy there to look at the atmosphere. And so I'll see y'all in the next video.